Learning about even and odd functions. So let's start off with a function that has y-axis symmetry, which just means that if you have any point, so for example this point right here, 3, 5, if you were to reflect it across your y-axis, and we know that if you reflect it across your y-axis it makes your x change signs, that point is also going to be a part of the graph. So every single point in this function, if you take any point and reflect it across the y-axis, it's also going to be on the graph. That is a function with y-axis symmetry. So if you have a point x comma y, that means negative x comma y will also be on the graph because that is how you reflect across the y-axis. A function whose graph has y-axis symmetry is an even function. So that's the definition of even when we talk about functions. So this is not talking about even and odd like the numbers. This is talking about functions. So now if you have a function that has symmetry about the origin, so we know that if you are reflecting across the origin, it changes both your x and your y. And again, if you pick any point, so if we pick this point right here, which is a comma 2, if we reflect it across the origin, it becomes negative a, negative 2. And so see how this graph, this point is still here, and it's still on the graph. Any graph that has symmetry about the origin is an odd function. So those are the definitions of even and odd. And today we're going to be looking at whether functions are even or odd. Now we can also be symmetric across the x-axis, which means that if you have a point x comma y, x-axis reflections change your y. So we have x comma negative y. But we don't have a name for this function because if you notice, this function, if you draw vertical lines, does not pass the vertical line test. So a graph with x-axis symmetry is not a function. Okay, so again, down here, a function is even if you change your x value to a negative, it still gives you the same point, right? So you get the same y value. It's odd if you change both the x and the y. So in this case, this is a negative x and a negative y, whereas in the even function, it's only a negative x. So notice how up here, even functions only change x, odd functions change both of them. Okay, let's take a look at what this looks like algebraically. So when we do this algebraically, let me first give you guys a couple of steps. So we're going to start off by finding f of negative x. That's the very first step when you have an algebraic problem. When you find f of x, you're going to see, does f of x equal f of negative x? So when you found this function, is that going to be equal to the function that you started off with? If yes, then it tells you the function is even and you're done. You don't have to do anything else. If no, then you have to continue and find negative f of x. So now you have negative on the outside. Once you find negative f of x, now you're asking yourself, does f of negative x equal negative f of x? Which is this part right here. So do these two equal to each other? If yes, then it's going to be an odd function. If no, then it's neither odd nor even. Okay, so this is really the flow chart that we're going to be following to figure out, is it even, odd, or neither? So let's take a look at our problems on the top of this page. So let's start off with this one right here. So f of x equals x to the third minus 4th. So according to our chart, our little flow chart, the first thing we're going to do is find f of negative x. So we're going to plug in negative x into this function. So instead of the x, it becomes negative x cubed. So when you're cubing a negative number, this negative sign, so negative x times negative x times negative x, stays negative. So this is now negative x to the third minus 4th. A good rule of thumb to remember is if you have an odd exponent, you're going to keep the negative And if you have an even exponent, it gets rid of the negative, right? So in this case, because it's a negative inside your parentheses and it's odd, you keep the negative. If it was even, like squared, it would get rid of it. Okay, so now we're going to check. Is this equal to this? So is x cubed minus 4 the same thing as negative x cubed minus 4? They're clearly not the same because this one has a negative and this one doesn't. Right? So we know that f of x does not equal f of negative x. So it's not even. So now we're going to move on down our flowchart and we want to find negative f of x. So this is when we put negative outside of the whole function. And we're going to distribute to give us negative x cubed plus 4. So again, we want to see, now we're checking to see if it's odd. So we want to see if, we're looking down here, f of negative x equals negative f of x. So does f of negative x equal negative f of x? So these two that we just found, is this the same as this? And as you can see, this one has a minus, this one has a plus, they're not the same. So because f of negative x does not equal negative f of x, the answer is that it is neither odd nor even. Let's do another example. So for this one right here, again, we're going to start off with f of negative x. So we're just going to plug a negative into our function. So instead of x, we're replacing with negative x. Absolute value, we know that absolute value just means the distance away from 0, so it makes everything positive, right? So this is actually the same thing. If it's a negative number, it's the same thing as absolute value of x. So now we're checking to see, is this the same as our original function? Yes, it is. F of x is equal to f of negative x. So because that's true, we know this is an even function. We actually don't need to go any farther. That's it. Okay, let's look at 4 now. So again, our first step is to plug in negative x. So right now there's already a negative on the outside. I'm going to keep that on the outside. I'm plugging a negative x where my x used to be. And now I'm going to add, again, I'm plugging in a negative x. Okay. So we know that this negative to the third power, because it's odd, it keeps this negative here. Since it's already here, we have another negative on the outside. So really this is a negative times a negative, which makes it positive. And over here, this is still a negative, so it's x cubed minus x. So is this the same thing as this? Nope, right? This is a negative, this is a positive, this is a plus, this is a minus. They're not the same thing. So because f of x does not equal f of negative x, this is not even. So now we're going to find negative f of x, where we put negative on the outside of our entire function. So I'm putting negative outside of this whole function. We're going to distribute it. Negative times a negative gives me positive, and then negative times a plus sign gives me a negative. And so negative f of x is this. Now we're going to compare this one with f of negative x. So look at the two that we just found out. These two are equal. So f of negative x equals negative f of x, which tells us that this is an odd function. So that's what we do algebraically. Okay, now let's look at some graphical ones. So on the graph, we're going to complete each graph for the given type of symmetry. And we're going to tell if the resulting graph is a function, and b, even, odd, or neither. So let's start off by looking at this one. We want to reflect it across the x-axis. We know if we reflect it across the x-axis, that makes all of our y's negative. So let's take our points. So we have this point right here. Let me just make a table. Negative 4, 3. Here's this point. This point is 1, 2. And this one is 4, 1. And then 5, 0. So if what we want to do is make all of our y's negative, that means I'm changing all of these to be negative. So instead of 3, 2, 1, 0, I'm going to make it negative 3. So negative 3, negative 2, negative 1. So now I'm going to plot them. So negative 4, negative 3, 1, negative 2, 4, -1, and 5, 0. So here is symmetry about the x-axis. So, A, is this one a function? Does it pass the vertical line test? No, it does not. So no, this is not a function. If it's not a function, is it even, odd, or neither? It clearly can't be even or odd, so it's neither, because even and odd are all talking about functions. It has to be a function for it to be even or odd. Okay, let's look at 6 now. So for 6, now we're reflecting across the y-axis, so that's changing our x's. So again, let me make a table of my points. So I got 0, 0, 3, 4, 6, -2, 8, -2, and 10, 3. And this time I'm changing my x's. So I'm going to make all my x's change. So before they were 0, 3, 6, 8, and 10. So now it's 0, -3, -6, -8, and -10. So they used to all be positive, now they're all negative. So let's plot them again. 0, 0, -3, 4. So I have -3, +4. Connect them. -6, -2. -8, -2. And -10, +3. So this is my graph with y-axis symmetry. So is this one a function? Passes the vertical line test? Yes, it is. B is it even, odd, or neither? So this is actually one of the definitions of even and odd. An even function means that it has y-axis symmetry. So this is even. Only our x changes. That's what even is. Okay, let's do our origin now. So with our origin, we're going to be changing both our x and our y. So again, let's start off with our table. We got 0, 0, 3, 4, 6, -2, 8, -2, and then 10, 3. And this time we're changing all of our numbers, both x and y. So let me actually do this in a different color so you can see. So we're making all of these change signs. So I'm adding a negative to all of these. This 4 becomes a negative. If it used to be negative, now I'm making it positive. So this is what I'm plotting. I got 0, 0, -3, -4, -6, +2 now because it's turned positive, -8, +2, and -10, -3. So this is what it looks like when it's been reflected across the origin. Is this a function? Yes, it is. The definition of even or odd, something that's reflected across the origin is an odd function, because odd is a function with symmetry about the origin. So that changes both your x and your y. Okay, let's do number 8. So for number 8, y-axis, again, we're changing our x's. My points here are 0, 0, 4, 3, 6, 0, and 10, -5. And if I'm changing my x's, these positive numbers become negative, and I'm going to graph it. -4, 3, -6, 0, and, oh, that's an 8, excuse me, -8, 0, and 10, -5. So that's what this graph looks like, kind of like a McDonald's arch. Is this a function? Yes, it is. Symmetry about the y-axis means it's even. So for number 9, notice it's the same points, so we're going to use the same starting points as the one we just did. But now symmetry about the origin means we're changing both our x and our y's. So these all become negative, and then the negative becomes a positive. So let's graph it. Now it looks kind of like a wave. Yes, it's a function. Because it's around the origin, it's odd. And our very last problem here, now we're flipping it across the x-axis. So we're changing our y. Let's just pick 3 points here. We have -5, 0, 0, 5, and 5, 0. And if we change only our y's, this 5 becomes a -5. So we're plotting -5, 0, which is right here, 0, -5, 5, 0. So I'm just connecting it around here. And no, this one's not a function. It doesn't pass the vertical line test. And so it's neither odd nor even.